Today we're going to start looking at some new material, specifically polynomial functions. And before we get started on working with them, we've got to determine what they are. A polynomial function is any expression that takes this form up here. So a times x to the power of n, and another a times x to the power of n, and so on and so on and so on. Okay. What that really means is I need to have some coefficients, all the a's, they have to be real numbers, and I need to have some x's with exponents on them. The key here is exponents have to be positive whole numbers. So I can't have negatives, I can't have fractions, I can't have decimal exponents, positive whole numbers. So I'm giving you some examples. X squared plus 3x plus 1. So I'd have like 1x squared plus 3x and minus 1. These are all real numbers. Okay. They all have letters in them, x's with exponents that are whole numbers that are positives. That's the power of 1. You could even think of this as the power of 0 if you wanted to. Okay, but those are all expressions that have coefficients that are real numbers, they exist, letters with exponents that are positive and whole. Okay. The second one here, x4 minus 2x. It's okay if you don't have all the parts and pieces. Notice there's no x cubed or no x squared or any regular old numbers. That's still a polynomial. It doesn't have to have all the parts and pieces, but it could. Okay. Some common polynomials that we're going to look at. And we have linear ones, like you did back in grade 10. So that would be, or grade 9 even. So this would be ax plus b. For example, y equals 2x plus 1. Okay, coefficients that are real. We have an exponent, that's a 1. Okay, it makes these kind of shapes. So we have quadratics. You did a bunch of that in grade 11, right? So 2x squared plus 3x minus 1. And all three of these exist, they're real numbers. And we have exponents that are whole numbers, right? 2, 1, and 0. Some new ones for us this year would be cubics and quartics. Okay, cubics are power of 3 functions. So for example, one of these might be 3x cubed plus 2x squared minus 5. Maybe it doesn't have an x term. That's okay, as long as I have real numbers for my coefficients and exponents that are positive and whole. Okay, and the fourth one, a quartic, that would be a power of 4. Okay, so maybe x4 minus 2x cubed plus 0.1x squared maybe. Okay. Again, my numbers, my coefficients are are real, they exist. It's okay that we have decimals for coefficients. It's the exponents where we have to have whole positive numbers. Okay, so again, those are all different types of polynomials. Okay. To talk about what type of polynomial something is, we need to look at its degree. The degree is the highest exponent in any one term. Okay, so the ones we just did a second ago, linear, the highest exponent, in this first one right here, would be a power of 1. So he says degree is 1. A quadratic, degree of 2. Cubic, degree of 3. Quartic, degree of 4. Okay, they may have other exponents in them, like the quartic one has a 4, a 3, a 2, a 1, and a none. Okay. Just to remember some things to point out. So A, B, C, D, E, those are just numerical values. They could be positives, they could be negatives, they could be decimals, they could be fractions. As long as they exist, these numbers don't really matter what they are. Okay, the key is their exponents have to be positive and whole numbers. And as I said on the previous page, it's not necessary for all of the terms you're present. You could be missing the cubes in here in this one, or just the regular old x terms. That's okay. Still a quartic function, degree of 4. Okay. And you don't necessarily need to put in order. In all these examples here I gave you, I went 4, 3, 2, 1, none. But you could have something that said, okay, y equals x plus x cubed minus x squared. It's out of order. That's okay. It's still a polynomial function. That would be degree of 3, because the highest exponent that I see is a 3. Okay. There are lots of other functions that we're going to deal with in this course, some of which we've already dealt with, okay, some of them we're going to deal with later, but just so we can recognize some things we come across that aren't polynomials. Okay, so the first one, obviously, one we've done already, sinusoidal functions, right? You see a sine or a cos in our equation, we know we're making the waves, hey, that is not a periodic. There are no exponents, and we have the word sine or cos in there. Okay, a second type, an exponential equation. In this form, the exponent is the unknown right there. Okay, we can't have that. For polynomials, your exponent has to be an even whole number. Well, x is a variable, so that is not a polynomial. And their pictures look like these ones down here. So they either go up to the right or they go down to the right. Those are only two choices for exponential. We could have radical functions. Okay, these are ones that involve square root signs. So for example, the square root of x squared minus 4. Okay, it's going to produce a picture that kind of looks like this. It goes off to one side, sort of like a half of a parabola on its side. Okay. You can also get those if you have fractional exponents, like power of a half. We said for us, polynomials, whole numbers and positives. Well, 1/2 is definitely not a whole number. That's why it's producing this non-polynomial function. And the fourth one, a rational one. These are always fractions with an x or x squared or x cubed or some sort of variable on the bottom. Okay, so like this right here, we have an x on the bottom. Okay, that produces a picture that looks like one of these things. They have breaks in the graph. Okay, that can happen by having an x on the bottom of your fraction or by having a negative exponent. Remember we said with polynomials, they have to be positive and whole numbers. So in these last two examples, we get the idea of here's a negative one, that doesn't work, and the one above it, there's a fraction one, that doesn't work. Those things are non-polynomials. Okay, so let's take a look at some expressions here. Can we figure out which ones are polynomials? If they are, what's their degree? And if they aren't, can you figure out what kind they are? So give it a try first, see if you can do it without me, and then if you get stuck, come back to the video and see what's going on. Okay, this first one is a polynomial. Okay, all my exponents are positives, they're all whole numbers, and the biggest one is the 3, so my degree is 3. Okay, letter B, it's not a polynomial. I know that because I got this x on the bottom. That is a rational function. Yeah, that's the name for it, an x on the bottom. All right, letter C. Letter C definitely is. It's a polynomial. Right, and it has a degree, I'm just going to use the letter D for degree here, okay? Or DEG maybe, of 1. I don't see it, but there's a little exponent of 1 right there. It's a linear function. Letter D. That is not a polynomial. I got a root sign in there, which means that this thing is a radical. And I just want to point out, a root sign over x is the problem. If it was a root 2, that would be okay. That could be polynomial. It could be something like this. But it's this one here that's the problem. You can't have a root sign over top of an x. Okay. E. E is a polynomial. That's the tricky one. This one's actually a polynomial with a degree of 0. Because we don't see the x. And the reason why it's an x to the 0. And the trick about powers of 0 is they always equal 1. So we don't usually show them. And that's a tricky one. So if you come across one of those things, you may remember that's a horizontal line. It's a weird one. And the last one here, is this a polynomial? For sure it is. Okay, it's a degree of 4. And the highest exponent I see is a 4. I have no negative exponents, no fractions, no weird things. That's my polynomial. Okay. Okay. In this unit, we're going to start drawing some polynomials. Now, you might be familiar with drawing linear things or quadratic, maybe. And if not, we'll review those later on. But if you get something weird you've never seen before, you should probably use a table of values. And just a quick refresher on those. A table of values, x and y, you get to pick whatever x's you want. When we did sine and cos curves, we did 0, 90, 180, 270, 360, because those were nice values for us. Here, because I don't know what I'm going to have, I'm going to choose what I consider the standard table. -2, -1, 0, 1, 2. And then I'm going to figure out what happens when x is that. So I'm going to use my function notation and say to myself, okay, -2 cubed plus 1. What's that come out to? -2 cubed is -8 plus 1. Oh, that's -7. Let's try f of -1. -1 cubed plus 1. -1 cubed is -1 plus 1 is 0. Okay. And so on and so on and so on. 0 would be 1. 1 cubed plus 1 is 2. 2 cubed plus 1 is 9. Okay, we get ourselves a table. Then we graph that table. Our x-axis is our horizontal, our y is our vertical. -2 and negative 7. It doesn't quite fit on my graph, so I'm going to estimate down there. Negative 2, negative 7. Negative 1, 0. 0 and 1. 1 and 2. And 2 and, oh, it doesn't fit my graph either, but it's about there. And then I'm going to try and connect these dots as best I can. And there is my cubic function, which kind of looks like the one we did a second ago when we talked about what different functions look like. Okay, if you come across something weird, make yourself a table. Let's try the next one. I'm hoping you think of this as a quartic function. You see a power of 4 there, so we know it's a polynomial. We're going to make ourselves a table. X and Y. Let's do our standard ones because we don't know what this looks like. Negative 2 to the power of 4 makes 16 minus negative 2 squared. Negative 2 squared is 4. So 16 minus 4 gives us 12. Negative 1 to the power of 4 is 1 minus negative 1 squared, also 1. I get 0. 0 squared, or 0 to the 4 minus 0 to the 2 is also 0. 1 to the 4 minus 1 squared. 0 again. This is weird. 2 to the 4. 2 times 2 times 2 times 2 is 16. 16 minus 2 squared, 16 minus 4 is 12. This is a weird table, right? We don't usually see things like this. We might need some extra values to figure out what's going on here. Maybe I should figure out what's happening between these zeros. So let's pick a number in between. Negative 0.5. And how about we do this one down here? Positive 0.5. If I use those values, I might get an idea what's going on between all those zeros, because that seemed kind of strange to me. So let's try it. Negative 0.5 to the power of 4 minus negative 0.5 squared comes out to, I'm going to stick it on this side, negative 0.1, try that again, sorry, negative 0.1875. And if I try the regular positive 0.5 one, 0.5 to the power of 4 minus 0.5 squared, and here I get, hey, I got the same number, 0.1875, and that's a negative. Okay, let's try drawing this best we can. It's a weird thing. Negative 2 and 12, that's like way off the top of my graph, way up here, right? Negative 1 and 0. Negative 0.5, and just below that, right there, and then 0, 0. And then positive 0.5 just below it, and then 1 and 0, and then 2 and 12 again, way back up here. So if I graph this, I guess I can go down, back up, down again, back up again, and go like that. Kind of like a W, but a really squished W. And that's kind of one of our hallmarks of a quartic function, is you usually get a W shape or an M shape. But because I didn't know how to make it, I used my table of values in my idea of function notation. I didn't show it this time, but I'm doing this every time, right? Negative 2. I talked my way through that one, right? Just to explain what's going on there. This would be 16 minus 4, which is 12. This is our idea of function notation. Okay, so there's polynomials. There's our introduction to it. Give it a homework that I'll try. See if you can try some of the quiz questions. Make sure you can understand what a polynomial is, how you can tell them apart from non-polynomials. And then we'll start looking more in depthly at different types of polynomials.